What is that sound? That is the sound of dripping alcohol. Dripping ethanol alcohol fuel that will work in your car that you can make on your kitchen counter. And this is how. To ferment alcohol, you need a bucket, a fermentation lock, sugar, 4.25 gallons of water, and some yeast. That's it. And the answer is yes, you can use regular yeast, the same yeast you would use for baking bread, to make alcohol. It'll make a wash of about 14% alcohol. Now let's get ready to start fermenting. Get your sugar and get your bucket. Now pour your sugar into your bucket. In this example, we're pouring in 10 pounds of sugar into a 5-gallon pail. Now add the water to the sugar in the bucket. Now I told you to add 4.25 gallons of water. So that would either be 4 gallons of water and then 2 16-ounce bottles of water, or 4 gallons of water and then 4 8-ounce cups of water. And a cup is 8 ounces. So in this case, you can either pour in 2 bottles of 16 ounces each, or you can pour in 4 cups at 8 ounces each, and you have your 1/4 gallon of water. Now mix it up real good, and in this case I'm using a clean piece of PVC pipe. Now add your yeast to the mix. This is again bread yeast. Now use the clean piece of PVC pipe to mix it up again. Yes, pure sugar and water has this greenish yellow tint to it. Now put the lid on the bucket. Now seal the lid onto the bucket. You might have to hammer it down with your fist. Now put on the fermentation lock. Now take the cover off the fermentation lock. Now put some water into the fermentation lock and fill it up to about this level. Now put it in a relatively warm place. 80-85 degrees is the optimum temperature. And let it ferment and bubble for 7 to 10 days. You will see the fermentation lock going up and down. Okay, it's 7 to 10 days, and you have a wash that looks like this. It's a whitish solution of fermented alcohol, yeast that's grown a lot, and water. Now go get your tabletop distiller. Use something you can dip into the 5-gallon pail to scoop out the wash. In this case, I'm using a 1-quart plastic pail. Start filling up the basin of the distiller. It holds just over 1 gallon of wash. As you can see, I fill it up to about 3/4 of an inch from the top. Now put the bottom of the distiller where you're going to start distilling. In this case, it's my photographic studio. Put the top onto the distiller, plug it into the bottom portion of the distiller. It's on the other side, you can't see it. And then plug it into your wall timer and plug the wall timer into the wall or a power cord. I'm using just a generic digital timer that I got from Walmart for about $8. I'm using this to turn the still on and off, so my distilling will be automatic. Generally what I do is I do not bother setting the time. I just turn it on at 12 o'clock. I set my first program to Monday at 12:05, and I set the stop time to be Monday at 2:30. This way I get an automatic distilling time of 2 hours and 25 minutes, which is the amount of time I need for this batch to distill out the alcohol of the 14% wash and to make about a 50% concentrated solution of alcohol in the receiver bottle. 50% would be 100 proof. And don't forget to put the timer on the automatic feature so it uses the programs. When the timer comes on, the fan in the top of the still will start spinning. You'll feel it and hear it. And this is what my test setup looks like. I've got the still, I got the receiver bottle, I have the hydrometer and flask. You'll see the hydrometer a lot for measuring alcohol. It is the simplest, easiest way. And at the bottom, I also have a refractometer, which is used for measuring low percentages of alcohol, which is here for illustrative purposes only. You will not need it in this demonstration. Now let's start this thing up and let it run for about 2 hours and 25 minutes. You'll see that when you start distilling, the product coming out, the distillate, is a higher percentage of alcohol. We just started and I'm getting 65% alcohol out already. That's from 14 to 65. That's pretty good. That's 130 proof. But this is just the first part of the distillate to come out of the distiller. A little bit later, you can see the percentage of alcohol is going down. I'm at about 62% alcohol right now. And now your timer may be different than my timer, and the amount of wash you have in yours might be a little different than mine, and your percentage alcohol might be a little bit different than mine. But the thing is, you want to start your timer at, say, 12:05, and you stop the timer, and you use this stop time for all of your first run batches. You stop it when the output of the distillate combined, all of it together, is running about 50% alcohol or 100 proof. This is how you know to set your stop time for all of your first run batches. So the timer has turned off the still, and you need to make your next batch because you have 5 gallons of wash and your still only holds about 1 gallon at a time. You need to wait about a good 30 minutes before you take the top off because it's hot. It's 212 degrees hot, and the steam coming off of it will burn you. So wear gloves and do it about a half hour later. Hey, look, in this example, I found that 2 hours and 25 minutes was not the amount of time I needed for this batch. It was 3 hours and 30 minutes. So my total run time for all of my first run batches, no matter how many gallons I have, because I could have fermented multiple buckets at once, it will be 3 hours and 25 minutes long. So from 12:05 to 3:30. Now in this example, because I have one 5-gallon pail and I have a reservoir on my distiller that holds about 1 gallon, I'm going to repeat this 4 times until the bucket full of 14% wash is completely empty. And I have quantity of alcohol distillate. In this case, I have a first run of about 50% alcohol. That's 100 proof. And in actuality, I don't have 1 gallon. I have about 2 gallons. Now, everything we did to this point was our first distillation. No matter how many times we put the 14% in and ran it, that's our first distillation. We are now getting ready to do our second distillation. Take the 50% alcohol you just made and pour it back into the reservoir of the distiller. As you can see, the hydrometer doesn't have to be in its own flask. Here it's floating in the still, and again I filled it up to about 3/4 of an inch from the top, and this is my 50% wash solution that I have made. I have about 2 gallons of this. When you do this second distillation, it'll go from approximately 50% alcohol and to something above 80% alcohol will be coming out of the distiller. Now, how do I set my time for my second distillation? Well, that's easy. I stop it when my complete output of the distiller is right at around 80% alcohol. That's 160 proof. Now, repeat this for the 2 gallons of 50% wash that you have, or if you have more than 2 gallons, you might have used more pails than I did, and so you have more. But this is our second distillation run. And as you can see, there is something left over in the distiller reservoir after we've gone from 50% to 80%. And this alcohol that's left over will not be wasted. As you can see, this alcohol is about 12%. Now this is good 12% ethanol alcohol that's left in the bottom of the still. We are not going to waste this. What we are going to do is when we make up our next batch of alcohol and we're pouring in our sugar and our water, we're going to take this leftover 12% and pour it back into the bucket. That way it's not wasted and it gets redistilled again, and we have a higher amount of alcohol that we're making. Okay, so we've completed all of our distillations of run number 2, And our final result is somewhere around a gallon of alcohol at about 80%. That's 160 proof. Now, what we're going to do is we are going to do our third distillation. And this is where we are going to pour into the reservoir of the distiller our 80% alcohol. And again, what I'm pouring into the reservoir, I'm always calling a wash. Even if it's 14%, 50%, or 80%, I'm just generically calling it a wash. What comes out of it, I'm calling a distillate. So, yeehaw! Look at this. The output of our 80% wash made a distillate of about 90%. Now, again, to set my timer, so I can do this over and over again on an automatic basis, my third distillation run, I stop when the complete distillation output is at around 89 or 90%. In this case, it's 89%. And as you can see, I have something less than or around a half gallon of 89% ethyl alcohol left. This is my end result of distillation number 3. I am now going to pour this back into the reservoir of the distiller, and I'm going to begin distillation run number 4. So this is 89% in, and I am getting only about 92% out. So I went from 89% to 92%. That's 184 proof. This is a good enough place for us to stop now and to get ready to utilize our alcohol fuel that we have just made. And I will have something just a little bit less than a half gallon of 92%, 184 proof alcohol. This is what my result is at the end of distillation run number 4 in the simple tabletop. Plug it in, set the timer, go on my merry business, still. Mixing alcohol and gasoline for use in your vehicle. What you need to know. The short answer is it's got to be 1983 or newer, because E10 or gasohol came out in 1983, and all the vehicles were formulated to have parts in their fuel system that would tolerate the ethanol. Yes, it'll work in older vehicles. No, it won't work in really older vehicles, but for the sake of picking a place, 1983 or newer. And now, to start off with a little math. Not hard. The proof of an alcohol is twice its percentage of alcohol in water. You've always heard vodka is 80 proof. Well, 40% alcohol is a mixture of alcohol and water. That is 40% alcohol by volume, ABV. This is a standard term. And it's 60% water by volume. So 40% alcohol by volume is 80 proof. So 50% alcohol is 100 proof, 80% alcohol is 160 proof, 90% alcohol is 180 proof, and very importantly, 95% alcohol is 190 proof. For mixing alcohol fuel, we want to mix half a gallon or half gasoline with half alcohol. So for 1 gallon of fuel, we want to mix half a gallon of alcohol with half a gallon of gasoline. Now the ethanol still you've seen in this video makes alcohol that is 90 to 92% ethanol. That's 100 to 184 proof. What happens when you mix 90% ethanol with gasoline in a 50-50 mixture? The answer is you can get separation. It's not totally mixed. You have a layer of gasoline, that's the yellow layer you see, and you have a layer of alcohol and water. This was mixed 50-50, but as you can see, only a portion of the gasoline dissolved in the alcohol and the water. So about the other 25% didn't dissolve. This is not what you want to have in your fuel tank. But the thing is, 95% alcohol and gasoline mixed together perfectly in any ratio. So let's take something that we know is 95% alcohol, or 190 proof. And as you can see by the hydrometer floating here, this golden grain alcohol is indeed 95% alcohol. And with the 95% ethanol, at 50-50, we have a complete mixture. No separation, no layers. It's all uniformly one color, mixed together perfectly. 60-40, 40-60, 70-30, 30-70, any ratio. They all mix when you're using 95% ethanol or higher. This is very well documented in the book, Alcohol Can Be a Gas, and is an industry accepted norm. So how do we get our 90% ethanol up to 95% ethanol so it will mix perfectly in any ratio with gasoline? There's two ways I'm going to show you. There's method number 1 and there's method number 2. But first, some math. Okay, it's not actually math, it's nomenclature. Here we go. What we call gasoline today and buy in the USA is most of the time what is really called E10. E10 is 10% ethanol, and the ethanol is 100% or 200 proof, mixed with 90% gasoline. This was done to boost the octane of the gas after MTBE was banned, went out of favor, and then the alcohol is also used to make an oxygenated gasoline, which improves emissions. This is too much information, and you don't need to worry yourself about it. I want you to know what E10 is when I mention it. Now, in the USA, in many parts, you can buy E10. That's 10% ethanol and gasoline. And in many parts, you can also purchase E85, which is 85% ethanol. And again, this ethanol is 100% or 200 proof. And it's mixed with 15% gasoline. This is what is used in flex fuel vehicles. This is why it's sold. So if you have ethanol that we are making that is 90% ethanol and 10% water, and you need 95% ethanol and 5% water, then you dilute your water in your 90% ethanol with the 100% ethanol that is in E85. And it mixes perfectly. This is 1/4 E90 ethanol that we made that had the 10% water. It's 1/4 E85, that is 85% of pure 100% ethanol, and it's 1/2 gasoline. So method number 1, which is very simple, and this is from me, Steve Harris. Okay, this is not something I picked out there off the internet. I came up with this formulation. I tested it on my lab bench, and it works, and I'm bringing it to you. You will not hear this anywhere else. This method number 1 is I took a 1/2 gallon of 90% ethanol that we made. We took a 1/2 gallon of E85 that I bought at the local gas station, and 1 gallon of gasoline that was E10 that I bought at the local gas station, and this gives you 2 gallons of fuel, 25% of which you made. So let's say we want to use half the fuel that we're making. We want to make half our fuel, not a quarter, because remember we're mixing half ethanol that we make with half gasoline to run it into a vehicle with no modifications. So method number 2 of the method number 1 and 2 that I told you, you use a 3 angstrom molecular sieve for water absorption. Okay, let me put this in more English terms. You use zeolite 3A for dehydration of the ethanol. Okay, maybe a little more English. You use these ceramic beads that will sell you, and it will absorb the water out of the ethanol. How's that? For your information, this is zeolite 3A, which is a 3 angstrom molecular sieve. And this is what it looks like. Ceramic beads that you hold in your hand, and you will mix this with the ethanol. And we will do this in a stainless steel cooking pot. And you can see here I have 93.5% ethanol, but yours might be 88 or 89 or 90. We have some zeolite 3A, and we have a thermometer. And as you can see, using a 3 angstrom molecular sieve in the form of zeolite 3A is extremely difficult. First thing you do is you pour in your ethanol into the pot. And then you pour in the zeolite 3A into the alcohol that is in the pot, and you mix it up. And after a while, which is documented in another video and instructions, we can see that you get almost 100% pure ethanol. You will get between 95 and 99.8% ethanol. This depends upon how much of the zeolite you use and how long you let it interact with the alcohol. This is a perfect ethanol to be mixed in any ratio with gasoline to be used in a vehicle. And the ratio we want is 50-50. 50% ethanol to 50% gasoline. For those of you who ask me the same question all the time about this, yes, this is the same ethanol alcohol you would buy as vodka. In places like New Zealand, it is 100% legal to make home distilled alcohol. In the USA, this is called moonshine. It is illegal to manufacture for the purposes of drinking. It's perfectly safe to drink. There's no methanol or anything else in there. It's just, it is illegal to distill your own home spirits. If you want to make alcohol at home for drinking, you can do so legally with beer and wine. In fact, the process described in this video is exactly the same way Grey Goose and other top shelf vodkas are manufactured. You distill it 3 times, and we did 4, and then you dilute it back to 80 proof with pure distilled water. Then you filter it through a carbon filter like a zero water carbon filter from Walmart or Target, and you get the highest quality top shelf vodka available. But this can only be done if you're in New Zealand or someplace in Africa where they don't have laws and enforce them. Get your tabletop distiller and measurement kit and other supplies below. Quantities are limited. We're taking orders and shipping them right now.
Recently I got a new car, and my old car is going to the junkyard. So I was wondering if it would run on moonshine without any modifications whatsoever to the engine. So I went out and I got a little bit of moonshine. Moonshine is generally about 190 proof straight out of the still, which is about 95% alcohol and about 5% water. This high test hooch, however, is about 99.95% alcohol because it's against the law to make moonshine. So what I did was I went out and I got straight methanol. Now the first question I had was whether or not the methanol and the gasoline would mix together. There's just a little tiny bit of gasoline left in the tank, and I thought, you know, maybe they would stay separated when I poured this into the tank. So what I did was I went and I put a little bit of alcohol in this beaker and a little bit of gasoline, and as you can see, they mix together beautifully. They're both hydrocarbons, so it's not too surprising that they are completely homogeneous. The next thing I want to do is a burn test. I'm going to take a little bit of alcohol and a little bit of gasoline, and we're going to light them on fire and see what happens. I have here a little bit of gasoline in this beaker. Gasoline burns at about 1950 degrees Celsius. Now, I have also here a little bit of that methanol. This burns at about 1920 degrees Celsius, which is a little bit less, but not a lot. Let's move this out of the way so we don't light everything in the world on fire. And now let's light that on fire. Well, it's burning and you can't even see the flame. I thought it was out. So as you can see, it burns a lot cleaner than gasoline. So after our burn test, you can see that the gasoline container is just covered with soot. It was only burning for like a few seconds, and you can see the discoloration in the glass. Compared to the alcohol, here you can see that there's absolutely no soot whatsoever. The alcohol burned much, much cleaner than the gasoline did. So this is like what's coming out of the tailpipe here. I mean, you can see all of the pollutants that would be coming out of your tailpipe as compared to the alcohol. None whatsoever. I mean, I'm sure there's some, but none that you can see on the glass. So here's the old girl herself. It's a Dodge Stratus. She has 363,000 some odd miles on her. I was hoping to drive her to the moon and back. I got there, I went around, and I'm on my way back. That's 477,000 miles round trip, but I didn't quite make it. She's got to go to the junkyard. You can see that the engine is just the straight old engine that was in it, original, very few parts, nothing added for this methanol experiment. It's just the straight up engine. It's got very little oil in it, I would imagine, because I haven't checked it in years. I'm gonna just put this into the tank. There's a slight bit of gasoline in the tank right now. It's probably, I'd say, much less than a gallon probably. It's way down on E, the gas light is on. So it's gonna start on the gas that's in the fuel lines right now and should run just fine. I don't know if we'll know when the methanol hits, but if we let it run long enough, it's certainly gonna start running on the methanol. It's gonna be a mixture of methanol and gasoline, but it's gonna be very, very little gasoline. For all intents and purposes, it's straight methanol. Okay, here we go. Okay, so now it's running on the little bit of gasoline that's in it. Got about a half a tank of gas now. Where before I had, well, it was on E, the gas light was on. So far so good. Right now I would say at the worst case scenario is that we're driving on about 90% alcohol. Well, that's not true. Let's say there was a gallon in the car, right? So that puts us at about 80% alcohol. This is just a regular car. It's not been designed to run on flex fuel. It's not a flex fuel vehicle. It's not made for E85 gasoline. But here we are driving down the street with at least 80% alcohol. I notice no difference right now in the way the car is driving. The idle is the same. Everything seems exactly the same. So we're going to drive it around until we used up some of this gasoline, and we'll see. So here we are, this is a 2005 Dodge Stratus, and we're running on alcohol. Almost completely 100% alcohol, at least 80% alcohol, and we're having no problems. There's no difference in the way the car functions. I mean, the car never functioned really well as it was, but I turned it off yesterday, it had very little gasoline. We turned it on today with mostly alcohol in it, and it's running just beautifully. Maybe it's going to eat up the rubber O-rings and stuff like that, but you know, as far as a fuel goes, alcohol is perfect. You could distill it in your backyard if it was not illegal and dump it in your car. If you had to, you could run your car on, you know, your kitchen scraps.